Next is properties of inverse trigonometric functions. We have several properties. Look the property number 1. Property number 1 already we discussed. Sine of sine inverse x, that's equal to x for all. This symbol is for all. For all x belongs to minus 1, 1. Here x we consider this one, sine inverse x. So what is the domain of sine inverse function? That is from minus 1 to 1. So for all x belongs to minus 1, 1. Similarly, cos of cos inverse x is equal to x for all x belongs to minus 1, 1. Tan of tan inverse x is equal to x for all x belongs to, domain of tan inverse is R. Cot of cot inverse x is x for all x belongs to R. Cosec of cosec inverse x is x for all x belongs to, domain of cosec function is R minus open interval minus 1, 1. And sec of sec inverse x is x for all x belongs to R minus open interval minus 1, 1. You have to write this in the notebook. Now the next property, property number 2, sine inverse of sine theta. So in the previous one, sine of sine inverse x, that x will be a number. Okay. Here sine inverse of sine, here it is angle. So sine inverse of sine theta is theta when this theta for all theta belongs to its range. What is the range of sine inverse? Minus pi by 2 to pi by 2. Then cos inverse of cos theta is equal to theta for all theta belongs to its range, that is closed interval 0 to pi. Tan inverse of tan theta is equal to theta for all theta belongs to open interval minus pi by 2, pi by 2. Cot inverse of cot theta is theta for all theta belongs to open interval 0 pi. Cosec inverse of cosec theta is equal to theta for all theta belongs to closed interval minus pi by 2, pi by 2 minus 0. Now the last one, sec inverse of sec theta is theta for all theta belongs to closed interval 0 pi minus pi by 2. This also we discussed. Now the third one, property number 3, sine inverse of 1 by x, that is defined as cosec inverse x. Then look the x values, x is greater than or equal to 1 or x is less than or equal to minus 1. That is sine inverse domain is minus 1 to 1. Here x is in the denominator. So those values we get when we put x as 1 and greater than 1 or less than 1 or equal to 1. That is why it is given x is right side of 1, 1 and greater than 1 and less than and equal to minus 1. The same way cos inverse 1 by x, that is equal to sec inverse x. Cos inverse also domain is minus 1, closed interval minus 1, 1. But here x in the denominator, so it is greater than or equal to 1 and less than or equal to minus 1. And tan inverse 1 by x is equal to cot inverse x, that x is greater than 0. Here we have to prove this property. So first property I can prove. First property is sine inverse 1 by x is equal to cosec inverse x. Okay. So let the proof is like this. Let y is equal to cosec inverse x. So we can write x is equal to cosec y. Okay. Y equal to cosec inverse x. So cosec y is equal to x. Now what is 1 by x? 1 by cosec y, that is same as sin y. So 1 by x is equal to sin y. So what is sine inverse of 1 by x? 1 by x is sin y. So if we take the inverse function, sine inverse, if we take the inverse here or take this, that way also you can think sine inverse 1 by x, that becomes y. And what is y? Cosec inverse x. So what is the result? Sin inverse 1 by x is equal to cosec inverse x. The same way you can prove the next. Cos inverse 1 by x is equal to sec inverse x, and tan inverse 1 by x is equal to cot inverse x. Now look, the 1 by x, property number 3, there are 6, but these 3 is not mentioned in your textbook. Whatever in your NCERT textbook, that only you have to learn. But I am giving this because sometimes you are most of the cases the children don't check this range and all, and you start doing problems, and after a particular stage you won't get the answer. So these results will helpful. Okay. So those who can by heart, you can by heart, others leave it, only the NCERT textbook, what is given in that book, that only you have to by heart. So look this one, cosec inverse 1 by x you can write as sin inverse x for all x. So this part is important. You don't think that these are important, just you can learn this much, that is no. You have to remember this, what is the value of x in which range, that also important. So here x is in minus 1, 1, minus 0. Sec inverse 1 by x is equal to cosec inverse x for all x belongs to minus 1, 1 closed interval minus 0. Both are same. Cot inverse 1 by x is tan inverse x if x is greater than 0. If x is greater than 0, tan inverse 1 by x is also same as cot inverse x. But if x is less than 0, result is different. It is pi plus tan inverse x. So those who can by heart, you by heart this. Okay. Now the next property, this is given in the textbook, property number 4, sin inverse minus x, that is equal to minus sin inverse x, and x is in minus 1, 1, that is the domain of the sin inverse function. Cosec inverse minus x is minus cosec inverse x. Tan inverse minus x is minus tan inverse x. Always these three functions are related. Cos, cot, sec are related. So here cosec range, look this range, mod x greater than or equal to 1. Mod x means it is plus or minus x greater than or equal to 1, that is x greater than or equal to 1, and minus x greater than or equal to 1. Minus x greater than or equal to 1 means x is, when we multiply by negative, this sign will change. Okay. So 1 and greater than that, or minus 1 and less than that. In between you won't get. Cosec inverse domain is like this. This is same as this. If this is difficult to remember, you can remember this way, no problem. Both are same. Now tan inverse minus x is minus tan inverse x, and tan inverse domain is real numbers. Now proof is there. Proof, first one, sin inverse minus x, that's equal to minus sin inverse x. We have to prove this. So let y is equal to sin inverse minus x. Okay. So what is sin y? Minus x, or x is equal to minus of sin y. Okay. That minus we can write inside, x is equal to sin of, minus sin y is same as sin of minus y. Sin minus theta is equal to minus sin theta. Then we take inverse here, sin inverse x is equal to minus y. Okay. Or minus sin inverse x is equal to y. What is y? Y is equal to sin inverse of minus x. Okay. So we proved. What is the result? Sin inverse of minus x is minus sin inverse x. Tan inverse minus x is minus tan inverse x. Cosec inverse minus x is minus cosec inverse x. The same way we can prove the second and third one. Now 4, 5, 6. cos inverse minus x. Cos sec cot. Look here, the answer is pi minus, everywhere pi minus that function. Cos inverse minus x is pi minus cos inverse x. Sec inverse minus x is pi minus sec inverse x. Cot inverse minus x is pi minus, sorry, here it is cot inverse x. Okay. So, we can prove the first result. Let y is equal to cos inverse minus x. Okay. So, when we take cos y is equal to minus x, or x is equal to minus cos y. This minus we can't take inside. Okay. Minus cos theta. Cos is negative in the second quadrant. Cos inverse range is that first two quadrants now. So, minus cos theta we can write as cos pi minus theta, pi minus y. Okay. This is x. So, what is cos inverse x? Cos inverse x is equal to pi minus y, or y is equal to pi minus cos inverse x. And what is y? Cos inverse minus x. So, cos inverse minus x is pi minus cos inverse x. So, we proved. The same way we can prove the next two. Okay.